Okay, now we're doing number 57, and we have to find the region, or the area, of the regions that are between the curve and the x-axis. So for those regions that are above the x-axis, we don't have any sign changes to make. For those regions below the x-axis, the integral of those regions will be negative, so we need to turn that value positive, so we'll multiply that integral by a negative. That way we get a positive result. And we'll add the three positives result, and that'll give us the total area between the curve and the x-axis. So let's see, let's factor first, and we'll factor a negative x out of both terms, and we get an x plus 2 here. And now let's graph x and y. And so our upper bound is at 2. By the way, we have a 0 at 0 and a 0 at negative 2. And our lower bound is negative 3. Now, our right-hand behavior is down since the leading term is negative. And we're going to go through 0, turn, go through negative 2, and go on. So, this is a region, it's below the x-axis. We'll multiply that integral by a negative. This region is positive, we don't have to worry about it, its integral is positive. And this region is below the x-axis, so we'll multiply the integral relative to this interval by a negative. So now let's find the area. And so the area equals, and starting from left to right, we have to multiply this integral by a negative. And we're going from negative 3 to negative 2. And now I think I'll factor a negative out of both of these terms, negative and x squared plus 2x dx. Good. And plus then the integral from negative 2 to 0, and we'll factor a negative out of both of these terms, negative x squared plus 2x dx. And minus, and from 0 to 2, and we'll factor a negative out of both of these terms, x squared plus 2x dx. Okay, now a negative times a negative is positive, so we just have the integral from negative 3 to negative 2 of x squared plus 2x dx. A positive times a negative is a negative, and we've got the integral from negative 2 to 0 of x squared plus 2x dx, and a negative times a negative is a positive, and we've got the integral from 0 to 2 of x squared plus 2x dx. So now the integral of this is going to be x cubed over 3 plus x squared, and we're going to evaluate from negative 3 to negative 2, minus x cubed over 3 plus x squared evaluated from negative 2 to 0, plus x cubed over 3 plus x squared evaluated from 0 to 2. When we evaluate this, negative 2 cubed is negative 8, so we get a negative 8 over 3. And plus negative 2 squared is plus 4. Minus, now, negative 3 cubed is negative 27 over 3, and negative 3 squared is plus 9. Minus, we have a minus sign there, and we'll evaluate for 0, evaluating both these terms for 0, we get 0, then minus, and now replacing x with negative 2, we get negative 8 over 3. Negative 8 over 3, and plus 4. Because negative 2 squared is 4. Okay, finally, we're going to get a plus 8 over 3 plus 4, and then minus, and replacing both x's with 0, we get 0. So now, let's do a little erase, and we'll see what we get here. So this, and again, area equals, and I get a negative 8 thirds plus 4, negative 8 thirds plus 4. Now, if you divide 3 into 27, you get 9, and that's going to be a negative 9 plus 9 is 0, so this thing just goes to 0. And a minus times a minus is a plus, and plus times negative 8 thirds is negative 8 thirds, and plus 4. And then adding these, I get plus 8 thirds, and finally plus 4. Now, a couple of these 8 thirds add out, and what we get here is 3 fours are 12, and minus 8 thirds. So when we get a common denominator, that's going to be 36 minus 8 over 3, and the difference is going to be 28 thirds, and there we've got it. That's the total area of the region contained between the curve and the x-axis, 3 areas.